Okay, one of the things we're going to be doing today, one of the main things we're doing today is I want you to be able to take words, turn them into algebraic expressions, and vice versa kind of thing. So here's what I want you to do first. On your whiteboard with your partner, please write down in a story problem, what are some key words that you would look for that would tell you to plus? Just write down a bunch of words. If you read a story problem, what tells you to add? Yeah, if your marker doesn't work, please throw it in the garbage. Don't put it back. Just grab a new one. All right, who's got one? What do you got? Some of. Perfect. That's a good one. Some of. What else you got? Add. Or the addition of. Same kind of thing, right? What else you got? Plus. Pretty basic one. What you got? Yeah, I mean that it's not a very common one. But that could be one. What else you got? How about just the word and? Yeah? What else you got? Anything else? How about increased by? You all right? Sure? Okay. All right. Now on another spot on your board, what do you think's next? Subtraction. What would be some phrases or words that would tell you to subtract? Huh? Then? Oh, less than. I like that one. Less than. Or really, just less. Less would be another one. Like 3 less. What? Yes? Remove? Okay, not a real common one, but definitely. Take away? Come on, what else you got? Decreased by. There's a good one. Well, there's another real common one. The difference. That's probably the most common. The difference between. Any more? Guys? Any more you come up with? All right, what's next? Multiply. Let's do multiply. Huh? Factor of. I mean, it's not a real common one. And actually, factor of, depending on its context, like what other words are in the sentence, you actually it could end up meaning divide as well. But if it says the factors of this number are, 3 and 5, that might tell you to multiply 3 and 5. So it could be. What else you got? What are some basic ones? Times. Multiply by. What's probably the most common one you'll see? Got that one. Huh? That's not the one I was thinking of. Product. The product of. Here's another, not the, but equal groups of. So you might see or hear something that says equal groups of 4. How many people do I have in class? 28. So that tells you to multiply those together. So that's another one that you potentially could see. But those are pretty good. By the way, when I wrote it like this, why did I do that? Why did I have an X and a little dot?
Because if they're doing like factors with X in it and stuff like that, you can't have the X because you'll get confused.
Yeah, once we get into this is algebra class, right? So we're in one of the next things we're going to talk about is like the alphabet. You're going to start seeing the alphabet in these problems. And when you start doing that, X is a very common letter that we're going to use. We'll talk about why X is a very common letter that we use. But if we have something that has an X in it and we want to use that as X, we can't really use that same symbol to mean multiplication, so we have to have other symbols. And most of the time, you're actually not going to write anything at all, right? Like if I write, what's the easiest way to say the product, the product of 2 and X? What's the easiest way to write that on a paper? If I say the product of 2 and X, just 2X. So do I put an X in there? Do I put a dot in there? No, you just write 2X. Yes? All right, what's next? Division. And yes, probably the most common one is divided by. Or just divide. What's another one? Come on. Anything. Could be a factor of, again, depending on how it's worded. Just like last one. Come on, there's lots of them. Huh? Got it. You're good at this.
Factored by?
Yeah, that's kind of the same idea. It's kind of, it really depends on how it's worded in there and what's given. Come on, what's the most common one? Somebody said it. Quotient. The quotient of. That's probably by far the most common one. That's probably about it. So, huh? For division? No, there's really not a lot for division. If I did, I'm sorry. So, everybody take a look at page 9 in your books. Get out one book, look at page 9. Again, the one thing we are working on today is I want to be able to take words and write some expressions. Now, before we get into some of those, there is some terms that we want to talk about. There's some terminology that we have to discuss. The first thing is, what is a variable? Okay, we use letters, or any symbol to represent what? Well, The answer most likely will be a number, but why don't we just put the number in there? Like, why do we need variables? So what a variable is always just used for is we pick a number or a letter to represent a number that could change. Or another easy way to think of this, it's just the unknown. It's the unknown thing in the sentence. If I say each of your homework assignments are going to be 10 points, right? How do you calculate how many total points are going to be in this marking period? Catch you later. How do you figure out how many
By the number of assignments, by the points divided by
So what's the unknown?
the number of assignments.
You don't know how many assignments there are, right? We don't know what that is. It could change. It could be 7, it could be 25, it could be 108. Who knows? So what we do is we pick a symbol, we pick a letter typically, to say we're going to take 10 and we're going to multiply that by however many assignments we're going to be. We could use the letter A. Why would I want to use the letter A? Assignments. That represents assignments. Or we could say 10x. Or if we really wanted to, we could write 10 smiley face. Does it really matter what symbol we use to represent that? No. With all of these, this is the variable. That's the unknown. We just want a placeholder. We want something to put in our equations, our expressions, to say this is what we mean. Now, why do we typically use x? Why x? Why not A? Why not B? Why not O? Why not I? What do you think? Well, we're going to try to get away from the multiply using x, though. Why not use a smiley face? Why not, for the sake of going 10 points times the number of assignments, let's do 10, and then I'll just draw. There's my homework assignment. Why not use that?
It's easier to draw next.
What?
It's easier to draw next.
What's the easiest letter really to write? Isn't it an X? Like it's just fast and it's easy? That's why. That's the reason we use X. It has nothing to do with anything else. And it also doesn't look like something else. Should we use the letter O very often? Why not? Looks like a 0. What other letters should we pretty much try to avoid if we can? L, like a lowercase l or an I, right? Like those kind of letters, if we can, we try to stay away from those because they look like other things, right? And O looks like a 0. So we try to avoid that one. The most common letters we're going to use are X, Y's, and Z's, A's, B's, and C's. Like, that's pretty much what we try to stick to. Sometimes you'll see M's and N's, but I don't really like using M's and M's very often because they sound too much alike, right? P's and Q's, they kind of get a little sloppy. And really, even an A, I mean, it's important to have the little tail because it kind of looks like a 0. But that's what a variable is. So there's some other terms that we want to talk about. What do you think a constant is? What do you think a constant is? What does it sound like?
Something that's constant, that's like a number.
Okay, it's going to be a number.
A number connected to it.
It doesn't really repeat. It's really just, what does the word constant generally mean? Stays the same. It's not going to change, right? If I say 10x, will this value change totally? If I plug in a 1, you get a 10. If I plug in a 2, you get a 20. If I plug in a 3, you get a 30, right? What if I put this? Which part of this will not change? The 5. This is what we call a constant. It doesn't have an x attached to it. It's just going to be a number. Because how would we solve this? We'd plug in a number, plug in a 5. We'd do 10 times 5 is 50, and then we're going to add 5. If I plug in a 6, what's the last thing you're going to do every single time? Add 5, add 5, add 5. This part is not going to change. That's what we call a constant, okay? Now, there's a difference between what we call a numerical expression versus an algebraic expression. What do you think the difference between a numerical expression is and an algebraic expression? What do you think a numerical expression has? Numbers. So an expression is more than one thing. So give me something that has multiple numbers in it. 1 plus 2. 8 minus 3. 4 times 2 minus 3. These are what we call numerical expressions. Can you simplify those? Can you evaluate those? 5, right? Numerical expressions are nothing but constants, basically. What do you think an algebraic expression is, though? And it's going to have variables. So it's going to be something like 3x minus 5, 7a minus 10, 8 smiley face minus 3. By the way, why don't we use smiley faces all the time? Because they're kind of fun. It just takes a long time to draw a stupid smiley face. It's just easier to draw an X, right? And you will understand this as we go, but mathematicians, a lot of times they get a little bit lazy, and basically they just try to find the fastest way to write things. It's really what they do. The key, though, is when you write something in math, every other person that reads that has to know exactly what you're talking about. So we want to abbreviate, we all do, like we just like writing less, right? But we also have to make sure that everybody else that reads it understands what the heck we're talking about. Make sense? All right, so here's what I want you guys to do right now. We'll just do this. Will you please, with your partner, write an expression. Write some words. Could be three words, could be 10 words. Give me a way to write that out in words. What would one way be? What would a simple way be? 8 plus x. What's another way? Write it with your partner. Write one on your board. Go. Think about all those phrases that we just talked about with plus. What is a different way we could say, think of all of these. What's a way we could write that? What's another way? What do you got? The sum of. How about this? The sum of 8, and you probably should write out 8, and a number. Does that make sense? Because whenever you see a number, what is that? Whenever you see this in a sentence, what are we always going to use for that? We know that's our variable. That's our letter. We're going to use A's, B's, C's, X, something like that. That's going to be that. Try number 2. I want two different ways of writing that. What's two ways I could write that as in words? What do you got? What's that? Ooh, be careful. And here's why. One of those two is correct. Which of these two is correct for this algebraic expression? How many of you think it's the top one? N less than 5. Or 5 less than n. Which one's right? The bottom one. This one is absolutely correct. This one's backwards. Right? This one would actually mean 5 minus n. Right? So with less than, you do have to, with any of the subtraction ones and the division ones, you have to be very careful of order. What's another way to write this? The difference of n and 5. That's a good one. The only thing I would like you to do is when you do these on your homework, I want one of them, feel free to use the letter. The other one, what I want you to do is change it to a number. Make sense? Okay, try one more. What would number 3 be? So number 3 says this. What are two different ways to write that? One of them use a number, the other one just use f. What do you got? F divided by 3. That's an easy one. What's a different word for that? Of 3. Is it 3 and a number or a number and 3?
A number and 3.
There you go. Are we good? Is there any questions on these? Okay, we also have to be able to go the other way. Everybody clear your board. I'm going to read something to you, and I want you guys to just write what I say in algebraic form. Okay? Sam is 2 years younger than Sue, who is Y years old. How old is what? How old is Sam? Sam is 2 years younger than Sue. Sue is Y years old. How old is Sam? What do you write? Y minus 2? Yes? Anybody write 2 minus Y? Because you're just going to take however old Sue is and subtract 2. Yes? Okay? Everyone's going to write this one and hold it up. William runs a mile in 12 minutes. Write an expression for the number of miles Will runs in m minutes. How many miles did he run? He runs a mile in 12 minutes. So every mile he runs another mile. Every 12 minutes he runs another mile, right? Write an expression for the number of miles Will runs in m minutes. What would you do with the m and the 12? I run a mile, or Will runs a mile in every 12 minutes. Another mile, another mile, another mile, another mile. He ran for m minutes. How many total miles did he run? What would you do with that? Ready?
Am I close?
Everybody hit reveal. Now, when in doubt, okay, because I got some differing answers. I got to divide the other way, I got to times. Now, what was the unknown? What was M?
The amount of time you ran for.
The amount of time he ran for. Somebody give me a number.
60,
How long did he run for?
64 minutes.
Let's say it's 64 minutes. Okay? He runs 12 minutes per mile. So every 12 minutes, he runs another mile. He ran for 64 miles. What would you do with the 64 and the 12? Add, subtract, multiply, or divide.
You divide 64.
You would divide. And what would you divide? Would you do 12 divided by 64 or 64 divided by 12?
64 by 12.
You would do 64 divided by 12. Yes? So, all you do is take that 64 and you turn it into an M, because we don't know what that is. So this would be right, or this would have been right. Right? Let's try one more easy one. Ready? Let's try an easy one. George drives 45 miles per hour. Write an expression for the number of miles George travels in H hours. He's driving 45 miles an hour. He drove for H hours. How far did he go? Everybody reveal what they wrote in 3, 2, 1. Are you going to add, subtract, multiply, or divide?
I need a moment to deliberate my answer.
Okay, what did I say? He's doing what?
45 miles an hour.
He's driving 45 miles per hour, right? He's in a car, driving 45 miles an hour, which means every 45 minutes he does what? Or sorry. How long does it take him to drive 45 minutes? 45 miles? 1 hour. Make sense? Okay. He drove for H hours. We don't know how long he wrote for. Let's say he went for 10 hours. What would you do with the 10 hours?
Divide 45.
You're just going to time. Every hour he goes another 45 minutes, or 45 miles. Every hour he goes another 45 miles. Every hour, 45 miles. Try one more. Ready? All right, this one should be a little bit easier because it's a little bit easier to visualize. The length of a rectangle is 4 inches greater than its width. The width is W. How big is the length? The length of the rectangle is 4 inches greater than its width. The width is W. How big is the length? What do you do with the W? So this is W. What did I say this is?
4 times greater than.
I said it's 4 inches greater than this. So how would you find this? What does 4 inches greater than mean? Add, subtract, multiply, or divide? Add. So this is just going to be W plus 4.
I got it.
Make sense? Now, the two main things that I need you to be able to do, and this is going to be a big skill. This is something that's going to follow you, not just in this class, but next year, the year after. These are things that you've been already doing for years. How many years have you been doing story problems? Since you can remember, right? I mean, my daughter's in 1st grade and she's already doing story type problems, right? And actually a lot of these that we're doing, she's actually doing in first grade. We're just trying to break it down and look for key words. If you see the phrase greater than, what does that tell you to do? Add. Okay? If you see the difference of, that tells you to subtract. Okay? A big skill that you need in algebra is to be able to take words and turn them into an algebraic expression. And vice versa. Good? Now, another skill that you need to be able to do is I will just say this. Solve. Evaluate these. What's the answer?
9.
How'd you get that?
Add 3 plus
We know A is 3, so what do you do with the A? Turn into a 3. What about the C?
6.
6? So the answer is 9. What do you do with this one?
Multiply.
What's the answer? 24? How'd you get 24? 4 times 6. Yes? What's the answer to this one? 2. How'd you get that? 6 divided by 3. Easy? That's really all algebra is. People get upset about, oh my gosh, there's letters now in math. How many times have you heard that in your life? Like, there's letters in math now. What you need to understand about the letters in math is all they are a placeholder. We just don't know what they are. Sometimes you're going to take the letter and replace it with a number. Sometimes we're going to actually try to figure out what that unknown is. How many miles did we just drive? We don't know yet. We're going to calculate that. How far did the runner run? We don't know yet. We have to calculate that. So sometimes we're going to be given enough information to solve it. Sometimes we're going to be given the number, and all we have to do is plug it in and then solve. Cool?